The essential question for today is how to draw a Lewis dot structure. So before we can continue on with understanding how and why atoms form bonds, we are going to use this shorthand notation to help us draw things a little bit better. So the question I'd like to begin with is typically this one. Review. Draw the Bohr diagram for calcium 40-20, right? So what we would do is not too bad. We'd be like, okay, we can do that. The 20 meaning that it's got 20 protons and 20 electrons. So you'd come over here and you could start drawing all 20 of those. Or perhaps at this point, we've learned the shortcut on how to do that. So we see that it is in period 4 and group 2. And so what that would do is that would help save us some time. We know that there's going to be 4 full rings followed by, sorry about that, there was a weird beeping going on. Followed by 2 electrons in the valence shell. But there's no need for us to really fill that whole thing out, because we know that the valence energy level, that outer shell, is the only one that's going to interact, and we know that every energy level up until that point had to be filled in order to be at the valence shell. So what we have then is this thing called a Lewis dot structure. And a Lewis dot structure, sometimes just called Lewis structure, only shows the outer or valence electrons. So in our case, what we would do is for calcium, to draw the Lewis structure, is you start with the chemical symbol. So it'd be Ca, just like on the periodic table, and then you just put in dots for each of the valence electrons. So in this case, since calcium has 2 valence electrons, we'd only put 2 dots. Let's take a look at some examples here on how to do that. So, nitrogen. Let's look it up on the periodic table. I'll slide up one more time. I'll zoom in there. Nitrogen is in group 15, so it's right there. All right, N, nitrogen. It's got 7 total electrons, but since it's in group 15, we know that that means it has 5 valence electrons. So, to start drawing then the Lewis structure for it, what we would do is we draw the chemical symbol N. And then what we do is we imagine that there's a little box, like a little square box around the symbol. You don't draw this in the future. This is just a way to help you think about it. And what we're going to do is we're going to put 1 electron per side on that. So since nitrogen has 5, we can start putting them in. There's 1, 2, 3, 4, and then you're like, okay, well, what do I do now? It says 1 electron per side. Well, once you get to 4, if you still have more valence electrons to show, you can then go back and partner them up. So it doesn't matter where they go, you can partner them at any point. I typically just put it up on the top. So that's what the dot structure for nitrogen would look like. All right, let's take a look at how you would do this for oxygen. Well, oxygen is in group 16, and so I'll just prove that to you. It's right up here in the periodic table. There it is. Oxygen, group 16, right next to nitrogen, so it has 1 more valence electron than nitrogen would. And so that would be a total of 6. So to draw the Lewis structure, what we do is we put the chemical symbol down, and then we start doing 1 electron per side. So 1 on the top, 2, 3, 4. All right, so we've already got the 4 there, and then we have to get a total of 6. So we can go ahead and partner that up. All right. Let's try sulfur. Sulfur is just below oxygen on the periodic table. It's also in group 16, meaning it has 6 valence electrons. And we draw the symbol, 1, 2, 3, 4 on the sides, and then partner it up. You'll notice that sulfur and oxygen have pretty much the same Lewis dot structure. There's 6 dots around them, and this is an important thing. It's why oxygen and sulfur have similar chemical properties. In fact, any element that's in the periodic table is going to have the same Lewis dot structure of all the other elements that are in that group. All right, so let's just go through this for a second here first. There's the Lewis dot structures. What I want to show is, like, for oxygen, this one is totally acceptable. It doesn't matter where the partners show up. Top and bottom is fine. But what's not acceptable is this one. So if you take a look here, we have 3 pairs, and then there's one side that's completely unpaired up. So that's not what you want to do, or you can't do. But the partners can show up at different spots as long as you've got 1 on each side first. All right, so let me go back and reiterate that point I was trying to show. So the Lewis dot structure for everything in group 1, because it has one valence electron, would just be a dot on the side. All right, so these all have one valence electron, so their Lewis dot structures would all be 1. Group 2 all has 2 valence electrons, and so they would go something like this. All right, group 3, because remember the part in the middle varies, so things get a little trickier there, more complicated. But group 13 with 3 valence electrons, so up here we got 3 valence electrons, all their dot structures would look like this. Group 4, I bet you know where I'm going. All right. Group 5, you're going to have the partnership, so they're all going to look something like that. And then group 6 with 2 partners but 1 free. Group 17, they're going to have everything partnered up with the exception of that, with 1 little extra. And then finally you get to the noble gases, which makes sense. Their Lewis dot structures are going to be 8 all the way around. Okay. So that's a Lewis dot structure. Now I did say that every element in the group is going to have the same dot structure. The one exception to this is helium, and that's because it only has 2, but that outer shell is still completely full. Okay. All right, so that's that. Hopefully you get that in your notes. The reason for drawing the Lewis structures is just a lot faster than constantly drawing out the Bohr diagram, and it helps us to be able to figure out where bonds are going to be. If you have any other questions, I'll see you in class.